I'm the user support specialist at CUAHSI, so I'm the point of contact for all the different services that we'll be talking about today. And then over here behind me is Jon Goodall.
Yeah, I'm Jon Goodall. I'm an associate professor at the University of Virginia in the Civil Engineering Department.
And John's been involved with a lot of the tools that we'll talk about today since really their inception, right?
Yeah, so I've been doing stuff with CUAHSI HIS and then now the HydraServer project. So going back probably 10 years now. So.
And today what we're going to go over, we're going to kind of do a half and half format where the first half, most of it is going to be slides that I'm going to be giving, where we're going to talk about NSF data management plans requirement as well as the process for publishing data with us. Then we're going to talk about the tools that we have to discover data with CUAHSI's, the Water Data Center. That's what the WDC up there stands for, the WDC's catalog. And then also how you can use our APIs to access the data by developing your own tools. So one of the really cool things that actually just came out first week in May was a R package for accessing data directly from the servers that are within our system. So we'll show you a little bit of that today. I also have a handout that has a tutorial for that, so if that's something that you're interested in, you'll have a nice, concise example of how to go through it. So a little background about CUAHSI. CUAHSI, it stands for the Consortium of Universities for the Advancement of Hydrologic Science Incorporated. We're a nonprofit that's primarily funded by the National Science Foundation to support research and education in the water sciences. So one of the ways that we really engage the community is that we're governed by the community. So we have a board of directors that are made up of faculty from all over the country in different water-related disciplines, and we also have a number of committees that specialize in advising on specific programs. So the data center, for example, has an informatics standing committee that advises us on how to allocate our resources. The other programs that we have at CUAHSI, we have a pretty extensive training program which involves instrumentation training, short courses such as small watershed science short course that's taught every year. And then we also do at least one and usually two series of webinars every year, so one with each semester. Then all those webinars are recorded and are available on our website. We also do a lot of education and outreach, as you might imagine. So we have a program called Let's Talk About Water that actually isn't funded by NSF. We have a private foundation grant that funds that, and that uses film to communicate lessons related to water science. So that's a little bit more of a whole community outreach situation rather than just, a specialized, graduate student or a situation like that. It's more designed to engage a larger community. We also have Pathfinder Fellowships, which is a really, really cool program. That's designed for graduate students who want to do some sort of comparative study, whether it's you have a field site at your home university and you want to go to visit a different field site, or you're working with a team at your home university and you want to go visit another team at a different university. We can provide funding for that on a competitive basis. We also maintain community resources, especially on our website, which is pictured there in the lower right. We have things like listings of graduate programs in water sciences, as well as job opportunities related to water sciences that we post on there. But what we're going to talk about today is primarily the Water Data Center program, and that was started. That funding began in April 2013. So we've entered our third year now. And we just went through a management review process that was pretty positive from NSF, so we're really excited about that. And everything that we do, everything that we talk about here is open source, and all the data are open and freely available. So, everyone here probably knows water data presents a number of unique challenges. It's really, really broad category, so lower right, you probably can't make out the terms, but that's our hierarchy of keywords for keyword search. So we have 4,000 different terms in that ontology that are divided into three categories: biological, physical, and chemical. Again, the data is really interdisciplinary. we're trying to make tools so someone from one discipline can publish their data and someone from a completely separate discipline can download that data, interpret that data, and reuse that data effectively. A lot of the data that water scientists deal with is dynamic and real time, so being able to accommodate sensor data is a goal that we're working to improve. We recognize actually right now our tools are probably not adequate for that, and that's something that's probably going to be coming up in the next year for us to really improve. And then, again, talking about how the data are all very interdisciplinary, the different end uses are very different as well. So it could be a scientific inquiry, it could be a decision support situation, or it could just be a classroom education and outreach situation as well. And by the way, if you guys have any questions while I'm going through these slides, just jump right in. This is not really meant to be too formal. So we'll get right into data management needs. Now this is going to be focusing mostly on the NSF situation. So you have a top-down NSF mandate for sharing publicly funded data. So that really started around 2011, where there was an executive action to really make all data that is publicly funded publicly available. And then that action was strengthened in 2013, where they moved a lot of that towards not only does it have to be publicly available, but it also has to be machine readable. So it has to be in something like an XML that can be incorporated into other systems and interoperability that we just heard from the last keynote speaker. So those types of situations. Then we also have the bottom-up approach where, naturally, there's just a desire to share and reuse data between individual researchers. So people want to share peer-to-peer because they can improve their research that way. So these are the different categories that NSF requires for your data management plan. You have to have a data inventory, so what exactly are you collecting? What are the standards you're going to be using? So how are the data going to be represented? But more importantly, that speaks to how well they can be reused and interpreted by a completely separate person or entity. There's also data use, privacy, and sharing concerns. So who can use the data? Is this truly going to be publicly available, or does it have to be private for some reason? Privacy concerns or what have you. And then the whole data lifecycle management. So how will the data be collected? What is the QC/QA process, and where are the data going to be stored in the long run? And so what we, CUAHSI, the Water Data Center, can help fulfill is requirements for both time series data and GIS data. And I'll speak mostly about time series data, and then the GIS, the spatial data hosting system that we started, it was a pilot last year, and we're trying to expand that this year. So I'll touch on that a little bit as well. So for time series data, the technology that we use that Jon was involved with in developing as a graduate student is the Hydrologic Information System. And it's a services-oriented approach, as we heard in Stefano's talk just this morning, where we have a central catalog that harvests metadata from servers and makes it available to an end-use client. So if we're comparing that to how the internet works, right? So you have Google, a big search engine. Google has, all these web crawlers that go out to the different data servers like Amazon or Colorado.edu or whatever. And then you have some sort of browser that allows you to search the catalog, and then Google directs you directly to the server via your browser. And we do the same thing. So we have an end user client. Hydra Desktop has been the traditional one, but I'll talk about some of the new tools that we have today. So that goes out, it searches our HIS Central Catalog. The HIS Central Catalog returns metadata, so the search results that match your search criteria. And then you're able to go out directly to wherever the server lives, where the data live, to that server to grab that data. And I'll show you what that process looks like.
You want to stand up, graphics?
No, I like sitting. Thanks, though. And so that's how the system works overall, right? So we have this kind of triad situation. But what ends up happening is data becomes standardized. And what's great about that, like I said, you're going out and you're searching the metadata catalog, but what you get back is returns from an infinite number of sources. So as many sources that have been registered with the catalog, that's what could possibly come back. And this could be a small academic project, or this could be the USGS catalog that we have integrated into our catalog as well. Also NASA data, some National Weather Service data as well, and EPA data. So basically you make one request and you can get data from all these different sources back to you. And this is how we accomplish this. Through a shared information model, which is generalized on the left. So if you're familiar with relational databases, this database is designed with the data values, the observations in the center. So you have a timestamp, the actual value of the observation, and some other keys that connect to other tables. And then, the basic tables that we have is one describing the location, so that's the sites table. The one describing who made the measurements or who made the model-derived data or whatever, which would be the sources. What's actually being observed, which is the variables, and then how it's actually being observed, which is the methods. And then on the right there is a screenshot of WaterML, which is a global standard for transmitting water time series data. And at the bottom is some control vocabularies. So certain fields, we define a restricted list of terms that are valid for those fields. And that helps us, again, with the reuse and interpretation of the data. So we have two, actually, semantic systems, and I've talked about both of them now. The ontology, which is from the catalog, that facilitates keyword search. And then we have a larger control vocabulary system, which is also, they're both available through web services, but the ODM control vocabularies is a little bit more in depth than the HIS central ontology, because the ontology right now is basically designed just for what is being measured, so whether it's dissolved oxygen or whether it's temperature. Whereas the ODM control vocabularies will get into things like what is being measured, whether it's the atmosphere or whether it's stream water, or it could be a site type, whether it's in a forest or a stream, or different situations like that. And again, both of these are available through web services. The HIS central ontology has a specific API call for that. And then ODM control vocabularies has web services related to being able to access and also update. So if you're maintaining your own database and you want to update your controlled vocabularies, we have a central database where you can go call the database and then update your local.
So is HIS ontology nested in the ODM ontology, and when I'm searching, am I searching using the ODM or the HIS?
So the ODM control vocabularies are typically more specific, and then the ontology will be more generalized. So you might have like a specific, really specific organic compound that is defined in the control vocabularies, but there's some more generalized term that we use for keyword search.
This ontology is a mapping between the ODM and
exactly,
like USGS.
So it is a mapping. So it's we basically derived our ontology from the USGS. That's how it started, I believe. And right now, the way this works is we maintain a mapping between the variables control vocabulary and our ontology. So if you conform to our control vocabularies for that variables field, then the process is basically, it automatically gets mapped to the correct ontological term.
So if you collect your own data and put it into a ODM database, then you would use the ODM control vocabulary. The ontology is like a higher level thing, and it maps out to USGS, EPA, as well as the ODM control vocabulary, right?
Yep. Thank you. So now I'll get a little bit more into the details of actually publishing data. So as I've said a little bit, this is a distributed system. So there are multiple options, including using our server, our cloud server, and our software. But you could also maintain your own server if you wanted to and use our software and register it with the catalog. Or there are other options as well, that as long as you conform to the standards that we use, then you can register the data in the catalog. But the general workflow is that, right, you get the data, however, whether it's a model or whether it's, you're going out to the field and observing. You format the data and metadata to comply with our information model. If you're using our server or if you're using our software, then you would attach a database to a SQL server and then load the data into that database. Then you set up a web service that basically exposes the data to the internet and gives it a URL that you could then register with our catalog. Then the catalog goes out and crawls it, like Google has the web crawlers. Then the data are available for search.
John.
Yep.
Is there something like version control in your software? Is there an option for that? So if you have a gauging station, there's a big flood, the cross-section totally changed, so you have to update your stage height discharge relationship. And you know this flood happened a few months ago, so you want to update your discharge record. But it's a different version, right? So is there something like that you can do?
So if it's that you've gone back and done additional quality control, something like that, we have a field that that defines the quality control, and that would create a whole new time series. So you would basically, if you had raw data, then you went back and QC'd it, you could have both data sets available, and they would be marked accordingly for the end user to know. So one really exciting thing that we've started, I guess it's been just over a year that we've been offering this, maybe a little bit longer, but is cloud data storage. So instead of what we were doing before is that we had a box server that was in our office that we maintained, but wasn't really scalable. And we're a pretty small staff, so that's important to us because we want to be efficient with our resources, and we weren't about to invest a large amount of capital into infrastructure. So using the cloud is really useful for us because we can scale on demand, and cost is calculated based on usage and not any upfront cost or any billing cycle that stays the same. It really depends on the queries that are happening. So if we get a lot of people that are trying to get data, then the cost would go up, and if a lot of people are publishing data, the cost would go up. But if either those go down, we can hopefully save a little bit money. And then all the data that we're talking about with our tools are uploaded in a CSV file format. So a typical workflow would be, you have your Excel sheet of data, you either run a script or you do a lot of copy and pasting into the correct format, then you take the CSV files and then you ingest it into our application, which I'll show you later. And then one last slide on the required tables. So this gets a little bit more into the information model. But we have the variables, so what's being measured, the methods, how it's being measured, sites, where it's being measured, sources, who's making the measurements, quality controls. I was just talking about, we have default values in there. So we have, by default, you have 0 for raw data, 1 for quality control data, and then 2, 3, and 4. And then data values, like I said, that contains the actual observations and the timestamp, as well as the keys to these other tables. So this is our new cloud-based application for uploading data. The two really big improvements that we made on this is, one, you can just open up a web browser and get to it. Prior to this, we had actually a desktop Windows-dependent tool that you'd have to install, then connect to your server. But with this, it's literally you're just signing on with a Google account. Then we set up your database behind the scenes, and then you can act on your own, but you're still using our infrastructure. And the second thing related to our older tools, our legacy tools, is that we actually have a validation step, which I found really useful because I've spent, in my position, a lot of time helping our community actually conform to the information model and make sure that to identify why things were being rejected, if they were being rejected upon upload, things like that. And here you can see what we have is we have 4 different categories. We have new, so records that are ready to be committed to the database, rejected, which are records that for whatever reason don't conform to the information model. For example, here, site code can't be empty. Here, lat long spatial reference system name, I simulated a typo, so instead of, for instance, NAD27, I put NAD278. And then we also have updated records, so if you update a record that has a same code, like same site code, and then you've changed something else, that'll update the record in the database. And then duplicates are exactly what it sounds, which are exact duplicates. Then the screenshot behind there is that's the landing page for the application, excuse me. So once you sign in, that's what you're brought to, and you have the different options of accessing user guides and templates, importing the data, links to our controlled vocabularies, and then on the right here is a summary of your database by tables, so you can see how many variables you have uploaded, how many sites you have uploaded, data values, things like that.
Can you get the wisdom, the URL for?
So right now you have to ask me what your WSDL is basically, and I send it out. So kind of the workflow is someone requests a database by signing in, filling out a form. The form comes to the CUAHSI staff. We set up your database and web service and then send you the applicable information for being able to register it with the catalog. We're hoping to streamline that process a little bit better, to make things a little bit more automated, but we're just not quite there yet. So what kind of data are being published? So I've basically seen, I like to think of them in two different worlds. We have the field observations, which could be, grab samples or continuous monitoring. So I've, the two diagrams or pictures there, someone doing grab sample at the USGS monitoring station. But we've also expanded a little bit into model-derived products. So typically gridded or raster data products that have been somehow spatially averaged or manipulated to convert into point time series. And I'll show you an example, which is the NLDAS in a moment. So different field observations, data sources that we have. We have local to regional monitoring projects, so this could be academic in nature. One of my favorite projects I've worked on is called the Shale Network. And this is a group out of Penn State. Also involved is Pittsburgh and Dickinson College, where they have been trying to collect as much water data as possible to discern whether or not there are impacts of fracking on water resources in Pennsylvania and the surrounding states. This has been a really interesting project because it's a collaboration between academic people, academic researchers, local government folks, citizen science folks, which has been really interesting to work with as well. We also have some local government bodies publishing data with us. An example of that is the Niagara Conservation Authority, which is basically just kind of showed up one day in the catalog, and which was great. And they just said that these tools fulfilled the use cases that we had, and that we've had that same experience with a couple other U.S. states. The New Hampshire Department of Environmental Protection has contacted me regarding that, as has the New Jersey. There might be a couple others, but I can't think off the top of my head. Citizen science groups, we do have a couple outside of that Shale Network project I described that publish their data directly with us. One is just outside of Boston. That's the Ipswich River Watershed Association. And in the R tutorial that I was talking about at the very beginning, when we were all, a couple of us anyway were in here, we actually used data from that data service for that particular tutorial. So you'll see that later is what I'm trying to say. We also have been trying to go out and bring in some of the larger external catalogs into our catalog. So a really good example of that is the USGS NWIS system, or NWIS, where we have written software that basically acts as a broker between USGS and us. We've done the same for EPA Storette, but we're right now in the process of replacing that with the new water quality portal, which will be really exciting. We also have the NSF Critical Zone Observatories. So they gather more data than just time series data, but their time series data is published within our catalog as well. And they have their own portal to access all the data, all their data. And then the last two, the SNOTEL data and Global Historical Climate Network, those were actually projects done by a graduate student who took at least subsets of those different data sets and then reformatted them and published them within our catalog. For the model-derived products, the best example I can give you is the NLDAS and GLDAS products. So these are global models that have been converted to equidistant point time series. And what's really great about these products is this is the first time we really had a global precipitation data source. So that was kind of the big thing for us when this came online about a year or two ago. And we have, I believe right now there are 3 of these services registered with the catalog, and then we have the TRIM data set also in the queue. We just haven't gotten around to getting that fully published and integrated yet. All right, so now I'm going to change. So we've talked about publishing data. We've talked about some of the people that are publishing data with us, and now I'm going to talk about a little bit how you can discover data and download data and maybe do some analysis with the data. The first way you can browse the different data sets in the catalog is by going to the actual catalog website, which is hiessential.CUAHSI.org. This contains a list of all the data services registered with the catalog and also has a description page that gives the opportunity for the publisher to give some details about the project or the situation where the data were collected and or manipulated. But for our tools, so for our applications for searching data, we basically have looked at, have used 3 parameters, and then we can usually limit. So if you know a specific data source that you want, you can usually limit to the data source, but really the traditional 3 search criteria are property measured, so whether it's temperature, dissolved oxygen, discharge, the time, so start and end date, and then the space, so where are you looking? So here's a screenshot of the HIS Central Catalog. This is a UMass, University of Massachusetts project, and you can see that we have the name of the data set as well as contact information up here. We have some descriptive statistics as well as geographic extent of the catalog. Right here is a health monitor, so we go out and ping every data service every day to make sure that it's up and running. And then you have an abstract and citation down here at the bottom. Clicking contributing organizations, you can access some grant information. So this was a feature request we had come down from our program officer, NSF, so that if he accepts our services as a data management plan, then he can go in and quickly look up to see whether the person has actually complied and published their data, whether the PI has actually followed through with that or not. So this is giving publishers an opportunity to cite funding sources, whether it's NSF or not. And it allows you to retrieve summary reports based upon granting agency and grant number. So here, this example was a project from Wilkes University that was supported by the Pennsylvania DEP, and then that was their grant number. This is their network ID in our catalog, the number of people contributing to the data, sites, and variables. This is Hydra Desktop, which I mentioned early on. So this has been our traditional data access software. It's Windows only and requires an installation, but it's a pretty powerful open source GIS tool, especially for entities or people that aren't willing to shell out the money for Esri license, something like that. This can be another resource available. And
this is built on Map Window, right?
Yes, it is built on that window by Dan Ames, led by Dan Ames out of BYU. So here I'm zooming into Boston area. I'm looking at the Ipswich River, so that data source I was just mentioning. I'm typing in all for the search keyword, so that will return everything. Typing in a search and end date, then clicking search. Now this is going out and asking the catalog what matches my criteria. Then this will return a number of sites. I can roll over each site. It'll tell me what is it being measured there and how many data values. And if there's more than one data service, then you can toggle back and forth between the two. It also has a quick download data now button at the lower right of that window. And then you can also open up the attribute table, which will give you exposure to the metadata. So to make sure whatever time series you really want, you can make sure that it has the number of data values you want, the variable that you want. The publisher can define whether it's a continuous observation situation or sporadic. And then you can just highlight, or you can sort, then you can highlight a row or multiple rows to click download. And then you can also filter based on text. So here I'm highlighting them all, I'm going to download them. Now it's going out to the server, grabbing the data, downloading it to a SQLite database on your local machine with Hydra Desktop. And you can graph in Hydra Desktop. And then you can also view the data in tabular form as well. And you can also export the data from Hydra Desktop as a CSV and to bring it in. And if you prefer a different analysis situation, if you want to bring it into Excel or MATLAB or whatever. This is a screenshot of our new tool, which is data.CUAHSI.org. So it's a simplified version of Hydra Desktop. right now, and it's web-based, which we're really excited about because we've been leaving Mac users out for a while now, and we're hoping to really engage them. One difference between this application and Hydra Desktop is in Hydra Desktop the sites are actually returned by data service, but in this new application they're going to be returned by time series. So each one of those little blue dots up there has a number of how many time series that are located there, and it's actually, if you zoom in and out of the map, they dynamically cluster. So if you zoom out, you can get a really big generalization of how many data points are in your study area, but if you zoom in, you get a more precise location.
I found that in HydraServer, it also has some data analysis tools. So why we both have the analysis tool in HydraServer and the application part?
In Hydra Desktop or HydraServer?
Both.
Because HydraServer doesn't really have any analysis tools. It's just, right now it's mostly data storage and data publication.
It's sure that it has time series analysis.
Yep, so that are some of the legacy tools. So time series analysis is a really, really great tool. It's really useful, but it's a Windows-only installation. So what we've been trying to do basically is to port a lot of these legacy tools that have been useful to the community to the cloud and to make them available via a website. So we haven't quite gotten to incorporating anything like the time series analyst yet. But a lot of that is also used for quality control, I believe, right?
Yeah, I think the part of the history is that from the CUAHSI project, there were many different collaborators, and there's a group at Utah State that developed time series analyst. And some of these tools get migrated up the chain to CUAHSI and maintained in production code, and some of it's left with PIs as their own kind of models they've developed or tools they've developed.
And those are typically all open source as well too. So what's really fun about the system is that if someone finds a tool like that and it's useful to them, they can still use it and play nicely with everything else. Then here, so if I click on one of those blue dots on the map, this is what's returned, a list of all the different time series. You probably can't see very well, but down here you have filter options. So if I want, this is GHCN, the Global Historical Climate Network, as well as, I believe this is SNOWTEL, but I could click this drop down, select one of those data sources, and the table would collapse to just those data sources, the time series from those data sources.
So why doesn't it just look like a grid with points if it has like an LDAS?
So some of it is, if we go back, some of these are going to be NLDAS, but so there's a couple things going on. We also have this, in this particular area, we probably have SNOWTEL data, EPA data, and USGS data, as well as probably academic data. It's not going to look like a perfect grid because all those things are being dynamically clustered based on a certain threshold of pixels. So everything's going to get shifted a little bit. And then if you zoom in, like if we zoomed in all the way, so the true time series were only displayed, like just their true location, it would look probably more like a grid. And then this new tool that I was talking about a little bit early on is really awesome. I'm really excited about it. I think John's really excited about it too. But it's a Kran Pack, an R package available in the Kran library that allows you to access data from our catalog. So the get services call allows you to pull down all the services from our catalog. The get variables allows you to grab all the variables from a specific server. Same thing with get sites, but sites, and then get site info will give you a little bit more information about a site at a specific server, then finally get values to access the data themselves. And then there's also some upload capabilities, but I believe right now that's restricted to one type of HydraServer, which is the data, what we call our data servers, which is a PHP base. We are maintaining right now a Microsoft basically base. So this I believe can upload to HydraServer Lite, but not to the HydraServer that CUAHSI right now is maintaining. That's what Yuri said, right? So, I mentioned this really briefly in response to a question, but, what's developing right now, which is really cool, especially related to, open source, just the open source philosophy is, a true ecosystem of distributed data, but also tools. So we have, the federal agencies that, CUAHSI is really taking responsibility for integrating, but, we also have a number of ODMs that we like to call, they're just out there in the wild. So, whether they're a university maintaining them, or, it could be a nonprofit, it could be, me at home.
For example, NWS data.
Yep.
Are y'all hosting that?
No.
So it's just reaching back out to
Yep.
USGS?
Yep. So the software that we developed, basically, they gave us a metadata dump to start with, so just a dump of their catalog. And then we basically built customized web services to be able to go request the data from NWS, return it, and then manipulate it to return correctly into our applications. And then, a growing data source, like I was saying, is the CUAHSI cloud storage. And these are all tied together by web services. So, I showed you Hydra Desktop, data.CUAHSI.org. We'll see this R, but, you can very well write your own custom software to access data as well. I know Jon has done that in Python a little bit as well.
You can do MATLAB, Python, anything that can kind of read these WSDL, like web service packages.
So if you're in the water board of a county or something, and you have a few stations, but you're interested in also, and so you have a client where people can visit those stations, and it could be in Watermill or something, and then you have your portal.
Mm-hmm.
Could you connect that to his central catalog or something, so you can also add USDS stations in your own portal?
Yes, you would be able to do that because the HIS Central API is robust enough to be able to have you call that API, return those stations, everything like that.
And the up package is based on the HIS Central API.
Yes, so it's based on, so we have the HIS Central API. We also have a suite of web services called Water OneFlow. So the difference is the HIS Central API is dealing with the metadata returns from the catalog, while the Water OneFlow actually goes out to the different servers to request the data.
Okay,
So the R package actually uses both. So like the get services, that's going to be an HIS Central API call, but the rest of these are going to be Water OneFlow calls.
and do we have like the Python package? Oh, now we only have the R.
So there's no Python package I'm aware of, so you would be making direct web service calls. So the advantage of the R package is that it provides like a wrapper, and it makes it much more intuitive in terms of getting it into the R data frames and all these objects that are native to R. So it makes your life easier if you're an R person. So in Python you can still go off and get the data, but it's not. You have to be a little more kind
Yes,
of
it's
comfortable.
use like the simple HTTP request.
Simple HTTP, there's a package called SUDS in Python that lets you do SOAP calls. So these are SOAP web services, usually from.
Yeah, we're still using SOAP. I mean, we were talking a lot about moving towards REST, which will make a lot of this easier, but.
But there's a package that, just a general package that lets you do kind of SOAP web services in Python called SUDS. And you can basically, I've got code if you want to see it sometime that lets you kind of do all these queries using that package.
Have you think of to transform the web service from SOAP to RESTful?
Yep, so that's definitely one of the things that's probably coming on sooner rather than later, so probably the next year, hopefully not more than that. But yeah, that's definitely on our list.
When we first built it, there was a big debate, SOAP versus REST. And I think now REST is gone.
Yes, SOAP is too.
But unfortunately, we can't just say you never know who's going to win.
So real quick, I know we're just about an hour here. I think we're going to take a break in a couple minutes, but this is a screenshot of our spatial data hosting service. So what the goal of this service is to be able to archive and make available GIS data sets that have been used in a peer-reviewed publication. So the workflow is basically a researcher will contact us, say that they have this data set they'd like to publish, that it's going to be in this peer-reviewed article. We issue them a DOI and work with them to come up with a map view that they're happy with. We allow them to put an abstract, then their publication citation, but also a citation for their data set. And then over here you can see the map layers and legends. So this is something I think is going to be useful for people to actually put permanent URLs into their journal articles that allow someone to go and grab their GIS data very easily. So this is kind of still mostly a pilot. Not to say that we can't expand and scale it up, but right now we only have one data source, one data set from one article that's out there, and we have another one that I've been working on getting it out there as well. So if any of you are interested in that, it's this type of thing. I'm a geographer, so this type of thing is really fun for me, and we're just using the Microsoft Azure Cloud again and Esri's Arc server to do this. So it's pretty basic tools.
Are you also able to have a permanent ID for a data set? I mean, are you pushing people, kindly pushing people to provide a permanent ID, such as DOI?
Yeah, so we actually provide the DOIs.
You are doing that?
Yeah, so we will issue the DOI for the publisher. So if any researcher comes to us and say they have this GIS data, they want to publish it using the service, we use Crossref to come up with a DOI.
But for data as well as document publications, I mean both, or?
So we do it for this landing page, and from this landing page you can download all the GIS data or just view it. Yep.
Do you know if it's going to get to where the office will actually get credit for the databases once they?
You know, that's what we're pushing. I go to a lot of meetings that we talk about how to motivate people to share their data so they get credit for it and it actually matters with their career progression. I wish I was in more of a position to say that, yes, you know, this is really going to boost your career, but I mean, the reality is, John might be able to speak to this a little bit more, but the reality is it seems like it's a slow-moving situation where, I mean, it's getting better. I mean, you see the stuff coming down from NSF, and you see the publications, all the publications talking about how to do this, how to increase your citations basically with the data as well. But I'm not sure there's any concrete path forward yet.
I mean, I think there's positive things like NSF, BioSketch moving from your 5 most relevant publications to your 5 most relevant products.
It's
As
a
being
huge
like a
step.
step in that
Yeah.
direction.
At least with the DOI, you can put it in your.
Yeah,
CV.
it'd make it look a little more official, right?
Yep.
Yeah.
Yeah, as a product. Yeah.
Then the last slide I have here is a new project coming out that John's actually involved with, so I'll let him speak to a few
Are
words.
you online at all?
I am online.
Go to beta.hydrashare.
I sure can.
So the way it's worked with CUAHSI is, so we had an NSF grant to develop this CUAHSI hydrologic information system, and so this is more of a research 5-year project. And then once we got to the end of it, we handed it over to CUAHSI to maintain it and for community support. And so we did that with CUAHSI HIS. We're doing that again now with this thing called CUAHSI HydraShare. And the difference between the HIS and the HydraShare is we realized with the HIS, limiting to only time series data, you know, that's only one set of data that we use as hydrologists. So we'd like to make it a lot more general. Can we publish any kind of resource? So might be your paper, your presentation, your data set, your model. So we're more of a resource-based publication. And if you go to, we have a beta site up right now. We hope to have it be www.hydrashare.org this summer. So you can still sign up for an account now if you want to play around with it, but there's no assurance that the resources are going to be maintained long term. If you top there, John, you go to resources. So the idea here is here's a whole set of resources. Each resource has a title, has a type, an author, and some kind of modification date. And the type there is what's kind of interesting. So we have a concept of multiple different types of resources. So one being a generic resource, you can publish anything you want. And then you might want to publish a geographic raster, or you might want to publish a time series or a model. And so for each type of resource, we're going to have particular metadata for that resource type. And as we get to hone in on what the actual resource you're sharing is, we can have a more informed page and metadata describing that resource. So if you just click on like the first one, for example, so here's just a generic resource that Dan Ames shared. And we were using Dublin Core metadata here to say, the abstract, a citation for it. You can share this with your friends. You can make it private and only give it access to certain people. You can do keywords. And so for generic, it's not that much different than other, just maybe putting it in Dropbox or something like that and sharing it. But the metadata, I think, is the real key here, and having a URL. And if you want to make this a permanent thing, we can actually assign a DOI to it as well. And I think the real power is going to be long-term, having these different resource types, having connections between the resource types, where you can see a data set, and then you can see what models use this data set, and have these semantic relationships between resources. For a particular model that you did, you can say, okay, I used these data sets to create that model. And then you can click on the data set, and you can see, oh, this data set was published by this group. And you can kind of see that whole kind of history in some sense of how things are connected. So that's the grand vision. I think that's where we're going to really see a benefit from HydraShare.
So, I mean, if I got it correctly, you are using Dublin Core metadata for also models, not just data, but also models.
So we start with everybody's Dublin Core.
Yeah.
And then when you become more specialized, we give you additional metadata.
Actually, this was my question. Have you extended it for
Yes.
specific resources?
So exactly, that's what we're doing. So this is a collaborative project with a lot of different partners. My group is thinking about for models and model instances, what is the metadata you would need to describe that? And so CSDMS has done a great job coming up with metadata for a model program, we're calling it, so the code. And then you might have an instance if you ran a model for a particular place that has a particular metadata associated with it. So back to your model web paper, and you have a particular way of describing this as well. So I think talking about how to do that would be really good.
I was very interested.
Yeah. So it's trying to standardize the metadata for models and model instances
And data,
and data sets.
Clearly, I mean, what you have said is very important point, how to connect data models.
Right. People, data, models, who's doing what, who owns what. Exactly. So the hope is, we're in year, I can't remember, 3 or 4 of a 5-year project. We try to get it up to the point where we can hand it over to CUAHSI. This becomes another community resource that's supported by their staff. That's our plan.
So that is all the slides that we have. I think we're going to take like a 5-minute break now. And then we came up with a handout that we're going to give to all of you guys, and we can go through the R tutorial if you want, or if you guys have specific questions or interests about anything else that you guys saw today, we can go over that as well. So why don't we just meet back in here at like 1:15, and then we can go through in some more detail some of these things.
So you're saying I can download all my gauge data directly into R?